Welcome to Through Inquisitive Kids. This is the first lesson of Chapter 7, Product of Powers. And it's going to be one of the lessons from the laws of exponents. Here's our course outline for our Chapter 7. Right now we're doing product of powers, and then we're going to be doing power of a power, powers of a product, quotient of powers. And those are all of the equations that are part of the laws of exponents. Using the scientific notation to rewrite smaller numbers. We're going to be learning to use a scientific notation, which also includes some exponents. And then we're going to be doing multiplying monomials and polynomials. And then multiplying just polynomials. And then multiplying monomials. And then we're going to be multiplying integrals. We're going to be doing the square difference formula, the perfect square formula, using the perfect square formula, dividing integrals, polynomials, and monomials. So we're going to be learning some really important equations that we're going to be using for later chapters. Here's our learning goals. I want you to keep thinking about these two goals throughout the rest of the video. 1. Understand and master the product of powers property. Use this equation to perform related calculations. Here's our introduction. A supercomputer uses 33.86 petaflops, 3.386 times 10 to the 16th power operations per second. How many operations can it perform in 10 to the 3rd power seconds? So since this is only the introduction, if you want to, you can do it yourself, but we're going to quickly go through this. 1. Write out the expression that would represent how many operations can this supercomputer perform in this much second. So first of all, I need to explain to you why over here it says Tianhe 3. Tianhe is the name of this Chinese supercomputer that we're actually talking about. So throughout these lessons, you're going to see some Chinese things because these slides, we actually translated it from the Chinese middle school math slides. What are the similarities between 10 to the 16th power and 10 to the 3rd power? So I want you guys to think about these two questions. This is the expression that you will use if you're actually going to be doing this problem. And what are the similarities between 10 to the 16th power and 10 to the 3rd power? Well, we know that their base number, which is the number on the bottom, are both 10, or they're the same. But their exponents on the top are different. The product of powers property tells us that when you're multiplying two terms that have the same base, you can just add their exponents to find your answer. We call the operation 10 to the 16th power times 10 to the 3rd power the product of powers property. So this might seem like a lot of words, but in the next slides you're going to be seeing a few examples and you will learn one equation from the laws of exponents, which is the product of powers property. Product of powers. Review. What is the meaning of 10 to the 3rd power? What does 10 and 3 represent in 10 to the 3rd power? This 10 is on the bottom, which makes it the base number. It might not always be numbers though. It might be expressions. It doesn't have to be just one number. Or it could be a variable. And the 3 on the top is the exponent. And 10 to the 3rd power means a repeated multiplication. And so in this case, it's 10 times 10, 10 times 10. There's 3 10s multiplied together. How do you rewrite 10 times 10 times 10 times 10 times 10 using exponents? All you have to do is count how many 10s are being multiplied together. In the end, your answer should be 10 to the 5th power because there are 5 10s. Discuss. What is 10 to the 16th power times 10 to the 3rd power equal? So please pause this video and try to figure it out yourself first. Now let's look at the solution together. So in the front, it's 10 to the 16th power. So there are 16 tens multiplied together. And then in the end, there are 3 tens multiplied together because it's 10 to the 3rd power. And then what they did was they got rid of the parentheses, so it's an entire row of tens multiplied together. So in the end, there will be 19 tens, because 16 plus 3 equals 19. So it's 10 to the 19th power. So basically what we did was we did 10 to the 16 plus 3 power, and then we got 10 to the 19th power. 1. Fill in the blanks. Can you find any patterns? And fill in the blanks yourself first. So this is a solution to the first problem, and in the blank you're going to get 7. And the answer is 5 for the second problem. This is basically just expanding. This is basically just first pulling out what the meaning of exponents really is, which is repeated multiplication, and then putting 2 groups of exponents together to fill in the blanks. 5 to the m power times 5 to the n power equals 5 to the what power? So again, you first write it out. And in the first parentheses, we have an m number of 5s being multiplied together. There are m 5s in this parenthesis. And in the second parentheses, there is an n number of 5s. Right now, even with variables m and n, it's still the same thing. It's just that the numbers are being replaced by variables. There is an m plus n number of 5s. After you erase the parentheses and put them all together, there is an m plus n number of 5s being multiplied together. So our result is 5 to the m plus n power. And then try this problem by yourself. A to the m power times a to the n power equals a to the what power? So same thing, it's just that the 5 is being replaced by a, which is another variable. And this is actually the product of powers property, and yeah, it's just this simple. If m and n are both integers, can you simplify a to the m power times a to the n power? How will you prove it? So basically you have to write out your entire solution with your answer for this one. So remember again, in the first parentheses, there is an m number of a's being multiplied together. And then in the second parentheses, we have an n number of a's being multiplied together. And then you take out the parentheses and put them all together. So then there's an m plus n number of a's being multiplied together. So in the end, when you fill in the blanks, it's going to be m plus n. Conclusion. Product of powers property. This equation is the product of powers property, and m and n are both positive integers. Okay, we're not going to negatives yet. The base number blank, but you blank the exponents together. So fill in the blanks based off of what we've already learned. The base number doesn't change, but you add the exponents together. So that's how you do the product of powers property. This is our class summary, and it's product of powers. This is what we've been learning about throughout this entire slide. But remember, when bases are not the same, you can't use the product of powers property. This is the equation. A to the nth power times a to the nth power equals a to the m plus n power. But remember, m and n are both positive integers. This is how you do it. The base remains the same, but you add together the exponents.